Hi, this is Thomas from Univox. A lot of you have already noticed that we've uploaded um, the new Univox Loop Designer, Univox Loop Designer 2.0. In many ways, it works exactly as the old one, but there are a couple of new features in this version that I'd like to walk you through. First one you will find on the very first page, we have a button called Duplicate, and what that does for you is if you highlight a project and click on duplicate, it will make a copy of that project, and you can go in and make changes of it, or maybe you're working on a room which is like identical to the other one. For whatever reason, you can duplicate that project. Then going into the project, under properties, we have a couple of changes. First change is that listening height is moved from properties down to figurations, and the frequency is renamed to source bandwidth. Also, we've made the 1600 Hertz the default setting, which is in fact it already was. We just called it speech instead. But the reason for this is in the updated standard, 1600 Hertz is the requirement. And what this means is that the loop system must must supply full power, i.e., supply 400 milliamps per meter up to 1600 hertz before it starts rolling off. It used to be 1000 hertz. Here at Univox, we always kept the 1600 hertz. Now it's in the standard. So that's your default setting. You can still override this. We took music out, which is very rarely used because it needs to be very complex music. But if you want to, you can still override this and put whatever frequency you want. I'm going to go back and bring it back to the standard level. Environment used to be called Attenuation, and what we have here are the fixed global dampening 1 through 12 dB. These are exactly the same as we had before. It just attenuates the whole field by the amount of the dB setting which you choose. But we've always made a huge improvement here, and this is our calculations both based on the global dampening, but also on our 50 years of experience in designing loop systems, on how metal interference will actually inflict on your loop design. I'll get back to this and try to clarify a little bit. Also, we have notes. So we'll bring up a new window for you, and you can enter whatever notes you have regarding this project. This can then be integrated with your PDF report of your project. Moving down to figurations, it looks much different, but it really isn't. To a large extent, it's exactly the same. We just made the area a little bit bigger, a little bit easier to work with. A couple of changes though. I've already mentioned the listening height, which has been moved down here from properties. Cable turns used to be called turns, with just a name change really. And this button here, this is the major change. You can inactivate the loop that you're working with. You may remember you can have as many loops as you can fit on this bar here within the same area. So very often, if you're doing, say, an airport or a train station, you're gonna try to fit more than just a single loop or just a single loop amplifier within that space. By doing so, you may want to have a look at each loop system individually. So what you can do is just inactivate whichever you don't want to see the graph on, or see the data results from. So just go in there, click on it and inactivate and save. Remember to save, because before you save anything in this area or any area, it doesn't go into your calculations because this is an online tool and works towards a server. Down here in loop conductors, a couple of small changes. You may remember this. We have three ways of connecting the cable to the loop amplifier, but if you work with a single core wire, there's only really one way that you can connect a single core wire to a Univox loop driver, and just to make that a little bit easier for you, we've taken away the other choices. So if you're going with a single core wire, you're going to be left with this only option to connect it to the driver. Also, the color that you'll display the wire in the layout is simplified. You no longer write the name of the color. You just bring down the scroll bar and you choose whatever color you want to. So I'm going to go with the green here. The rest of this works exactly the same as what you're used to. Then moving down to results, I'll make the screen a little bit bigger. The project data, there are no changes here except for one part. We used to have one part where it suggests a couple of different wires that you could also work with. We felt that this information was not really necessary for you when designing a loop, so we just simplified and took that out. The layout, as said, here you can see the wires displayed as green. It looks exactly the same as they used to, but with this one change. You have an export button here. What that does for you is you click on it and it exports this as a picture, and you can use that picture to integrate on maybe you have your drawing as a PDF file or something, so you can take that picture and you can integrate it with your PDF to show how the loop will be installed on your drawing. The 3D, this works exactly as you're used to. There are no changes in this area. The 2D field, though, this is interesting. You can also export this just as you did the design. But if you click on data, you have the option of displaying a curve for each frequency. So I just added the 5k hertz. You see this is displayed here how as a red curve. You can see how that differs from the 1 kilohertz. I can add 2500, 1600, and so on. Worth mentioning is that, as I said, the new standard will be based on 1600 hertz. We still chose to keep the 1000 hertz graph as a standard, but don't be surprised if we very soon upgrade this and make the 1600 hertz the default setting. You can also display what this would how this would have performed under free field conditions, just to see the difference. And also, if you click on source, this is a little bit difficult to understand. All this really does is that it highlights your default value. It makes it a little bit easier to see. So, not hugely important. You have the exactly same thing in the combined view, where you have your layout on your left side and your 2D graph on the right side. You can do exactly the same over here. PDF, though, was moved. I think this button was up in properties on the older version. Difference here now is you can choose which parts that you want to be exported into your PDF file. So if you only want your layout, you're just going to keep keep the layout, take everything else out, or you want to add your 3D field, maybe, depending on who you want to present these. All the information does not have to go into your report each time. Also, I said notes. You can add the notes or take the notes away. Again, you choose what goes into the report. Moving back to the 2D, so I'd show you what the difference is between the global dampening and the new settings. Let's start with free field though. So I'll save that. I plot that. See how little difference it is here. It's only maybe a 2 dB difference from the weakest point to the strongest point, and that doesn't change if you use the fixed global dampening. I can even go down to my 7 dB. I save that, replot it, and all it does is just takes down that entire curve by 7 dB. The variation doesn't change, and that's not how metal interference works. This works fine if you're an experienced loop designer, because you know how metal interference will work. You know that you cannot do large area loops in conditions where it will be exposed to metal interference. Over here at Univox, we don't allow larger segments than I think is 5 or 6 meters if we're working in a rebarred area. But you still have the flexibility of attenuating the whole field in accordance to whatever results you may have if you've done an on-site survey. But if you go with the fixed settings, and this will be the most common one, this will more accurately display what the metal interference will do to the performance of your system. So I plot that, and immediately you can see. Let me do this. Make this a little bit bigger for you. Immediately you can see what it does to the difference, the variation within the area. Here at its strongest point, it's 4.65 dB, and down here, place my cursor there, it says minus 2.66. So the difference from here to here is more than the 6 dB variation, which is allowed by the IEC standard. So this cannot go below -3, and this cannot go above +3. So that lets you know that you need to change your design, and the easiest way to do it would go to I'd say probably an SLS. Let's do a no stop loop. Save that. I replot. So let me use this view. Replot. I have this design instead. It's still a little low. I can add a bit of current. 2 dB. I think maybe that's too much actually. I replot. Well, it looks decently. It's okay. So it's +3 there, and almost -1 there, and I have a system that will perform according to standard. So that's how you can use this to work with. Those were the improvements in Univox Loop Designer 2.0.